This conference will now be recorded.
All right. So I wanted to start with this quote from Lord Kelvin. He's a physicist. I think it was a really interesting quote because to me, what it really represents is that mathematics is a language, right? And just like every language, different languages have different sets of tools that let them express different things. Math is a language that's composed entirely of things that only directly mean what they mean, right? So every other language has words that are subjective. There's connotation and denotation, but math is a language that forces you to describe something in a way that's definitive and to really talk about what are the relationships in a definitive way. And I think that's also core to architectural logic. You know, when you think about the way that we lay out our buildings, the image on the left is just as much of a parametric system as the image on the right. It's really about talking about relationships. How are those relationships interacting with each other? How do objects interact with each other? And how do we describe those relationships? So when I talk about Grasshopper, and I just wanted to bring it up in a way that it's just about understanding the type of things that you want to express, right? And so I wanted to start with a project that I did 2 years ago, which was a robotically fabricated pavilion, about 10 by 20 by 14 feet tall. It's all nail laminated timber. And the image on the left is a parametric model that was made in Grasshopper. And it's modeling all the elements and all the connections. And it was fed to a robot which produced the thing on the right. And so I wanted to sort of talk about how the organization of this thing comes together. It's this post and beam structure in the middle, this floor above, an exterior wall, and then an interior surface. And the same way that I describe these different elements is the way that the script is organized to generate this geometry. And so the way I thought about it when I was trying to design this project was trying to think about the elements, how do they organize together, sketching out how the interactions work, and then going into Grasshopper and basically breaking down a surface into lines, into geometry, and individual nails. And so I wanted to sort of show how that script actually works in practice and just bring that up. So this is that parametric model that I showed you guys, but we can't build the whole thing. And the way I said that it's made up of individual pieces. It's an exterior module, this outside piece here, and then an upper piece, and then a lower piece, and then this column and beam. But then to put it in a truck, we actually had to break it down into even smaller modules. They're about, a foot wide. That's about 100 pounds. But it's just all nail laminated layers. At the end of the day, it's just layers. And because everything is organized in the sequence that it's going to be built, at the end of the day, this whole script is broken down that I can pick each piece. Each piece is, and then look at each piece's nails. And so it's organized in a way that as I move through this list to say which piece, so you start with like the first piece, it goes through the first layer, and then it goes to the next layer, and then it goes to the next layer. It's just the sequence that it's being built, the nails, and just to show you how that actually gets executed. So on the right are all the modules in a truck, but then we feed this data into the robot and it builds it, right? And on the left, you can see how the modules stack up. I'll make this full screen. On the left, you can see how the modules stack up. Basically, that same order that the Grasshopper script was organizing those pieces, nails, that organization is fed to the robot, and you can just build these modules. And so we took those modules, put it in a truck. This is actually next door to Elkis Manfredi. This is the Autodesk Tech Center. Right there is the corridor that we all walk along to go to work. And then, so then we shipped it to Chicago, where we assembled it on site and built this pavilion. And so it was just trying to think about how you could take this overall idea and execute it in a way that you can have freeform geometry, but still communicating that geometry directly to a machine. But I really wanted to bring it up in a way that it's, when I designed this, the script was organized in a way around it was organized around the way it was designed. So this was all designed in layers. Its faces nail laminated on top of each other. And so in the Grasshopper script, I described it that way. I organized it by layers and sequence of which way to the robot. So yeah, I just wanted to show it to be a primer to understanding how everybody's projects are different, and you're going to have your own way of coming up with geometry and architecture, but it's just about taking those systems and understanding how they relate mathematically, right? And describing it in a script. And so we're going to show you something deliberate, right? We're going to show you in the next 40 minutes, something like a deliberate way of putting together a script. But that's really just a reflection of the way that we are breaking down a geometry. But throughout all of this, I think you need to be thinking about your own projects and the way you break down geometry, and thinking, what are the things that, how would I describe that in math, right? How would I speak of it in that mathematical language? Because if you can, then you can describe it in a way that computation can understand it. And we as a group, we want to come together and really figure out, how do we take that mathematical idea and express it with this script so that it can be a platform, something you can replicate it, so that it's not something that you have to go through that process every time, that process is a system, a platform that can be deployed on a large scale. And so yeah, just as a framer, because I think it's about the digitization of architecture, which is like, we're still very much in the Wild West of all this. Everything we're doing here is, bringing it into construction, and construction is very much a paper-oriented industry. And so everything we're doing here, there's not really a set solution, but that also means there's a lot of opportunities. So yeah, I think we just need to approach it that way, that, we might not understand everything, but everything can be understood given the time. So I think I'll hand it over to Tom to give us the intro into Grasshopper.
Great. Thanks, Anish. To just touch on this past topic, I mean, this is a very applicable, but also a very technically advanced application for Grasshopper. But it's really nice to see like what's possible. And I had the pleasure of actually seeing this pavilion get built in the tech center. And Anish is a new member of our fabrication team. And one of our goals is to continue this effort in mass timber and robotics at the tech center together. So hopefully you'll see more of this to come. This initiative with Grasshopper is really just a way to help clarify what the tools are, how we might practice with them, and just to kind of get everybody up to speed who's interested. So today will be sort of an intro to Rhino plus Grasshopper, as we call it, and we're just going to go through step by step. If you want to open Rhino and follow along, please feel free to do so. If you want to digest this later, we are going to record and share it with everybody. And what we built today and the Rhino models that we built, they will be saved on the drive, and then you can access them and utilize them at your convenience. So don't feel like lost. If you have questions, maybe put them in the chat, and we can try to get to them at the end. And if not, we'll hit them in the future. I'm going to share my screen, and what you should see is a blank Rhino canvas. Is everybody with me? Great. So right off the bat, if you open Rhino, you're going to see 4 viewports, a bunch of tools and commands, And it might look a little bit similar to some platforms you've used, or maybe not. So you have your files and your opens and all this good stuff across the top. You have a tab-based system for different tools. And if you're a new Rhino user, we're going to go through some basics, but also feel free to go to McNeil's website, who is the maker of this software. They have some really great upfront tutorials if you want to learn general modeling. So I'm going to start with drawing some simple geometry and sort of work you through a little bit of the Rhino interface. Then I'm going to open Grasshopper, and we're going to use that geometry to sort of quantify it and organize it the way that Anish was describing the timber pavilion. So I'm going to focus on the left toolbar here, and you can see that there's sort of points and lines all the way down to surfaces and further down to volumes and things. So I'm going to stick in the 2D sort of world, or the flat world, with lines and surfaces. And I'm going to build with those. First, though, I want to show that there's sort of 4 viewpoints. And if I want to go into perspective, I can double click. I can orbit, I can zoom, very much similar to SketchUp or Revit or other programs you use like CAD. And if I want to get out, I can just double click. So you'll see me do a lot of that. I'll try to explain what I'm doing as I'm doing it. Over here on the right, you can see that I have a properties toolbar. A nice thing about Rhino is if you hover, it'll sort of tell you what things are. And layers, like you'd see. So these are sort of default layers, which I can change color. I can turn them on and off. I can lock them. And I can even rename or reorganize as I see fit, which is pretty important. So I'm going to double click and get inside a perspective view. Up here in the command bar, you can see that if I want to type a command, let's say the letter C, for example, it's going to show me every single command in the program that starts with the letter C. So if you're not familiar with the lingo of curves or surfaces or what have you, if you're close or if you start to learn the nomenclature, you can sort of search and find things that maybe you didn't know existed even. I find that to be true for my own practice. So what I'm going to do first is I'm just going to draw a simple line. Here it's called a polyline. And I'm going to use the origin and just draw a horizontal line. Maybe I'll draw it about 100 feet. And I just type that in, and I'm going to hit enter or space bar. I'm going to zoom out to see that 100-foot line, which is quite large. There it is. And I'm going to select it. It's called a curve. And I can see that by up here in the command line. It kind of tells me everything that I'm doing as I'm doing it. Rhino is very great in the sense that numerically and mathematically, therefore a sphere is a sphere, and mathematically in space, everything is sort of described and imagined and can be organized. I'm going to type a command called extrude curve. CRV is the acronym for curve in this software, and extrude is just one of those commands that you'll know and love. And I will hit enter. As soon as I do that, I have the opportunity to kind of click a Z height in space, or in the command line, it's asking me in bold letters, what's your extrusion distance? And I'm going to say I want to do just 100 foot by 100 foot, let's say surface or rectangle. So it looks a little like a wireframe. For different viewports and boundaries, you can go into this little drop down, and there's an option called shaded. So there you see my surface. You can also see my line. I'm going to change the color of my layer to something like orange. So that's just a surface from a curve. And let's see what we can do in the Grasshopper side of things with something as simple as a surface. And we're going to be focusing on what's called a grid structure or a rectangular grid, and sort of panelize this rectangular plane. So Grasshopper is inherent in the software. So all I'm going to do is type the command Grasshopper and hit enter. And what you'll see is a pop-up with a Grasshopper. And it's going to start to load a lot of components. So basically in Grasshopper, you're going to see, I'm going to say every single command that's in the Rhino platform. And you're also going to see commands that have been sort of bundled together to make new and interesting ways of working mathematically. So as this loads, Great. Don't worry about the getting started. That's just places to start with tutorials and things. If you want the help menu or tutorials, cool place to start. I'm gonna close that out. And just as with the Rhino platform, you have all the things you know up here, maybe not Pancake or this other thing, you know, file and open. These are saved out as Grasshopper documents, which you can open in a Grasshopper environment. All these tabs are toolbars. Some of the more advanced ones are things that you can download, and we're going to be exploring one called Lunchbox today. But let's start from scratch. I don't want to open anything, so I want to start new. And I'm just going to double click on the platform. And the double click, the right click, and the zooming and panning are sort of the way to navigate this space, whether or not it's with your mouse or with the keyboard. And it's sort of search based again, just like you would search a command in the Rhino workspace. So I built a surface, and my logic tells me that there's probably a surface command in Grasshopper that I can use to say, well, let me at least set surface. So if I type surface, there's a what's called a node or a command called surface, and I can put it on the canvas. And I'm just going to zoom out and show you that this canvas is sort of never ending and can be as long or as short as it pertains to your project or your need. We're going to build, I think, like a half a dozen pieces that look like this or so, and get some information off of that surface or grid. Right now it's yellow. If I hover, it's going to tell me it's looking for a surface. It contains a collection of generic surfaces. This is sort of something that goes along with every Grasshopper node. You can hover and it'll tell you what it is. In different nodes, you can even see what inputs or outputs there are. This little flag says the floating parameter surface failed to collect data, and that's absolutely true because I haven't done anything yet. So what I want to do is go back into Rhino, and if I right-click on surface, there's a whole bunch of things I can do. The one thing I'm really interested in doing is set one surface. So in Grasshopper, it wants to read information, and then you can do things with that information. So you need to start to set geometry or parameters to start to analyze, and then it can give you feedback on your data in a plethora of different ways, more ways than we can even imagine to discuss today. So I will set one surface, and I'm going to click that surface. And now you see that what was once a yellow or an orange is now gray. It means it's reading a surface. And when I click on it, it's going to preview what I have in Rhino space. Okay. And then the question is, well, what do I want to do with that surface? I want to panelize it. I want to make rectangles out of the rectangle. I'm going to go into, I have many, many tools. This one's called Lunchbox. I believe you all should have it too, if I'm not mistaken. And under Lunchbox, there's a ton of stuff, but I'm going to go into this panels component. One of the things that we can do is make quad panels. It creates quadrangle panels on a surface. Great. I want one of those. I also want a grid. I want a surface grid. So I'm just going to type the grid. There's a rectangular grid. There's all types of them. Another one, grid on surface. Okay. But I'm going to stick with quads for now because it'll give me surfaces out of my surface, basically. So it again is orange or yellow. And if I hover, it's going to say, what surface do you want to panelize? What are the divisions in the U direction? And what are the divisions in the V direction? And that's sort of like X and Y. For here, it's sort of, you know, X and Z because it's in orientation vertically. I'm clicking on this node, which is creating what's called a wire, and I can put this wire into the next plugin or node. So this is an input, surf, U, and V, and I'm just going to plug that in. Automatically, you see that there is now a grid on my original surface. If I hover over U, it's saying that it's dividing the grid 10 times in the U direction and also 10 times in the V. I'm going to use something called a number slider to control those values. I want to change them. I don't want 10 and 10. I want it to be what I want it to be. I'm also going to double click, and I'm going to change the range of this slider. I'm going to change it from something like 0, or let's say 2, because you don't really want to divide anything at 0, to maybe something like 40 as an integer. I'm going to copy, I'm going to paste, I'm going to plug in 2. You'll see right away that update. I'm going to slide this up to something like 30 and plug that in. And now you can see that I can take these quads or panels and start to divide them at any dimension I want. I'm sliding. I could also double click and be very specific about the number that I want. All right. So what happens there? What just happened? What did I do? I took a surface. I told it to divide it. Why is that even important? I'm going to do something called a panel. And a panel is a little bit different than something like an architectural panel. It's a panel that shows data. And I can see what output I just input. You'll see all these surfaces that got generated from my one. To be exact, there are 1,050 of them, counting 0. How do I organize 1,050 panels? How do I extract anything from this information? And this is something that Anish and I thought was really important to try to hone in on, especially for that projects in robotics. So here we go. There is a command called list item. Now, this panel has sort of created a list, right? From 0 through 1,049. Those are all panels in this example. I'm going to simplify it quite drastically so we can just focus a little bit simpler. Now we have it. So if I want to take the panels, and this list item says, what is the list? What is the index or item number of that list? The item number being 0 through 4. And we are able to extract that item by itself by using a command slider to say what item we want. I'll double click. I'll say it's from 0 to 100. And now I can select anything in that list. Here's my new list. And I'd like to select item 0. There's item 0. And here's 1, 2, 3, 4, 5, right? And they're all organized in a way where I can select them. Okay. From my item, I can say very specifically, maybe I want an area of that panel. Maybe it's a window panel, maybe it's a solid. And this sort of alludes to what you can do with facade design or geometry, window-to-wall ratio, or just understanding surface area in general for general materiality or how much material you might be using on a project. I'm going to take my my extracted item, which right now is panel 0, or this one here. And you see that I can click on it, and it's sort of a center point or an area point of the centroid of the area. What I'm going to do from there is I'm going to extract or show what that area node has given me in terms of information or data, numerical data. It was asking for geometry, which I gave it, which was this item, which is just a surface from the panels. And the output is either the area, which is a number, or the centroid, which is a location, which is also pretty cool as a way to find the center of very organic shapes, for example, which we'll show in a second. What is my area? That's my area in square inches because I'm in an inches file. Okay. I can also do things like graphic previews. And I think this is important because maybe this doesn't look so hot to some folks and you want it to look a certain way. And that's not going to get, pardon me. I would like to preview the rectangle that I was looking at by using a preview command and what's called color swatch. I want to choose something like a color blue, I can just double click and pick a color. And now all that is what I see. There's a lot of information in this document. I can select it all if I want. I can right click. And there's a little button here called preview. If I want to turn everything off, except for that blue square, I can even hide my geometry in Rhino. Turn this preview off as well. That's sort of what you're done. Interesting enough. Now what's really cool, and this is the last thing I'm going to show you before I pass it off to Anish, is going to take you one step further and show you sort of an applicable design process for architecture. I'm going to do a command with an F10 key, and it's going to turn on my control points for this rectangle. Okay. You'll see in my script, everything kind of went dark or different colors. I made a change and I lost my information, but that's okay because I'm going to change everything. I like to freeform sculpt in Rhino, and I think it's a really cool thing to do that other softwares don't let you do as freely sometimes. You notice I'm making this sort of double bending rectangular geometry. And the idea is to panelize it. And because it's still a surface, I can right click, I can set one surface, and everything I did before is still there. I'm going to turn on my previews. I'm going to turn on everything I had on before. And we can see that the area has changed live on that list item number 0. And let's make things a little bit more fun. We can start to divide this thing. And if I make a big change, everything change this area, or if I change the panelization, I'm just going to drag this over here for a second. Yeah, as I move, that number moves. So this could be floor plate areas, for example. So I'm going to pass it over to Anish, and he's going to show you the next sort of logical approach to why this geometry might be applicable.
Great. Thanks, Tom.
You got it.
All right, just check. Okay. All right, so let's start with the blank template. I mean, are there any questions from the crowd just before we move on, just about like working with Rhino, Grasshopper?
Yeah, how'd I do? And I'm always open to train folks in Rhino or Grasshopper, one-on-one or in groups. Definitely just reach out.
Okay, so this is just based around just taking a block. Let's say now that we all know, I'm going to try, you can just do the box command just to make a box, right? And I'm working in feet, so I'm just going to make a really big box. Right? And then I'm going to go to Grasshopper, and I want to bring that box in. And so three-dimensional objects in Grasshopper, or really any geometry object, can all fit under the comment of you just put it under geometry, right? Everything is geometry. So we can just do geometry, right-click, set one geometry, get you there, right? And so now we have this object. And we want to extract floors from it. So let's use a contour command. So if I type in the contour command, plug the geometry into the surface, let's get a slider. So it's asking for the B-rep or mesh to contour, a start point, it's 0, 0, it doesn't really matter. It's just going to start at the origin, which is just that red point right there. The normal direction, right now it's 0, 0, 1. And so that's an XYZ coordinate. So it's pointing up, right? So it's going to contour your object up from starting at the base of the model, a set distance, which it doesn't have. It doesn't have a number. So I'm going to plug this guy in there. So that's 0.25. You're getting a lot of contour. So let's make this really big. Let's make this like 10 to 100. Start with 10. Okay, so now we're contouring this every 10 feet. And if you're modeling the different scales, just make it a number that sort of makes sense, right? If your thing is, I'm doing 10 foot floor to floor, but maybe we want to do like 14 foot. Depends on what your scale is, right? So what we have here is all these contours. So if I make another geometry and plug that in, we can see what are we getting out here, right? We're getting the lines, the contours of this VREP. And there's 7 values, right? So it's all 7 contours. And so like Tom said, we can get the area of all those contours, and you can use a panel. You can type in panel, but there's also a nice little dash gets you panel. Great shortcut. And so you see that it's broken up right now, right? It's there's a bar under here, there's a bar under here, there's a bar under here, and so it's not like one big list. So if we actually right click on the A and do flatten, we flatten this whole list into these multiple lists into one list. So let me do 2 versions of that just to explain the difference here. So this is unflattened and this is flat. So you can see that all these numbers, each one of these numbers is in its own branch. This branch is called 0, 0. This branch is called 0, 1. This branch is called 0, 2, etc. But when I flatten the list, it's one branch called 0 that has all 7 of these values. So that's how you get, that's how you can, even though it's sort of the same thing. And then there's also another thing called mass addition. So if you have a list that's flat and you want to add all the numbers in that list together, you can plug it into the mass addition and get the result. So you can just add together and say, oh, so all 7 of these floors together are 234,690 square feet, right? So if you have a mass, you want to get your floor to floor heights and get your area, that's a quick way to immediately get that number out there. But then let's look at the contours again, right? So the contours are these, let's look at actual lines, right? It's these polyline curves, right? It's the rectangle, 4 lines in a circle. But if I want to get these individual lines and know, let's say I want to know what is the length of this face versus that face or something, right? You need to take that polyline and explode it. Do we have a question? And then explode it, right? So now let's make another panel. I just like doing panels along the way. You can always delete them later, but just as a way to check your work, it's like a math problem, you're checking your work as you go. Just looking at what your result is and putting those panels out there so you can really visualize it. So you can see we have these branches. So we have, if you highlight it, it's 28 values in these different branches, 1 for 4, right? So it's each one of the rectangles, it's 4 curves, and they're all in this very long name. It's 0, 6, 0. So I'm going to show you another trick, which is called when you simplify. So when you right click on the S and you do simplify, gets rid of all the chaff in the naming, right? So before it was 0, 4, 0, 0, 3, 0. Sometimes when we put a geometry through a lot of different steps, it adds a lot of extra names. But just to simplify it, you can do the simplify command and it gets rid of all the extraneous naming, right? If there's really only 3 things, it'll make it simple. So now we have branches, a branch for each one of the rectangles with all 4 lines within that rectangle. So let's do the preview thing, custom preview, and try that so we can see this. Material, right? Custom breed material. No, what is this? Swatch. Oh, swatch. Color swatch. Let's say I want to make all these. I like purple. Boom. Oh, so there's also the previews. So when you have, we need to turn off all the other previews to see that. So let's turn off all the previews. So now you're just seeing these purple lines. So that just that again, if you just select a bunch of stuff and then right click off of it, you can do preview off and it'll just turn them off. But then if you want to turn them back on, preview on, preview on. So we got some lines, there's our floor lines. And so we've got this, and let's sort of visualize how this whole system is laid out, right? Let's type branch, and you get the tree branch command. Let's just delete this guy. Plug this in there. And let's make another slider. A number slider, edit, make it an integer, because the list, the branches and items, there's no decimal points in them, right? It's all just integers. So let's say we had 0 to 7, but let's make the range to 10 just because we can. Plug that in. So now you see highlighted in green, branch, the 0 branch of this list, right? So it's all this purple stuff, but the green is just the first branch. So while I'm highlighting this, while I have this clicked, I can go to the slider and adjust the slider, and your preview that you have selected will adjust automatically, right? So that's a good way to just be able to say, okay, what is branch 1? What is branch 2, 3, 4? So you see that it's going up, right? And then even within that, so there's 4 lines. You can see that there's 4 lines in that branch, right? In this bottom branch, middle branch, all of them are rectangles, right? So 4 lines, but you want to see which order those lines are in. So we do list item. And so the difference between tree branches and list item, tree branch is like your top, the higher order. List item is the very bottom. Like once you get down to just a list of data, list item is what's looking within a branch to say, okay, what is, so if I plug this in, and then I maybe get the slider from over here, copy it, just plug that into there. Now I can see, if I click on list item, I got to turn off tree branches preview because it's cluttering. Let's turn off all the other previews. You just see one thing. So now, list item. So it's just picking one item. Oh, there we go. It's on this face. So the second one is actually the 0, 1, 2. So 0 is actually the first item in a list. So 0, 1 is on the other face. 2 is that way, right? And so you can even, if you right click on list and do reverse, you can reverse the order of the items within the branch, right? So now, maybe an easy way, so 3 is, so if I show between 2 and 3, right? 2 and 3 are around this corner, 2, 3, 2, 3. But if I reverse it, and it's like the whole list just wraps around. So then 2 is like on the other side. So that's just how you can see how the list is actually organized within it. So now I can say, okay, I have this one line, and maybe I want to know the length of that face. So you do double click length, and then you'll see length, measure the length of a curve. And plug it in. And you can see the value. It's 182 feet long, right? And so let's get the other one, right? It's 183. And so I can even take this box and start shifting it and you know, if I look at this length, my length will update live. Right, so as we change this object, or maybe I bring in a whole other object from somewhere else and plug it in at the very beginning, we can just apply that same process to it and still run that same analysis. So then let's talk about how to, oops, I probably should have done that. Okay, so let's talk about how to manipulate this box, turn this box into a building, right? Going back to what Tom was showing us with panelization, you'd have a wall, and how do you put this grid onto it? How could you turn these contours that we have? I'll turn off all the other preview stuff we were doing over here. So we have these contours. How can we start to break this geometry down into facades? And so, you know, we saw how this was organized before. The branches where you go, it's a rectangle stacked on top of each other. But now if I want to get faces, what I want are branches that are not organized by the rectangle horizontally, but branches that are organized by the lines of the facade stacked on top of each other. So like the same way that we had, you know, this line, right? I want one branch that has all of these lines in it. So this list is sort of organized the opposite way. And so Grasshopper has a function for that called flip, and flip matrix. So if you do flip matrix and plug it in, and then let's take the panel over to the flipped matrix and see how does that look in comparison. So now, if we take this flipped matrix and plug this back into the tree branch stuff that we had before, now you can see we have a list organized by the lines horizontally, right? One branch. So if I go to the next branch over, like the branches is this whole set, and then one branch, another branch is that line. So we have all the branches, right? And so then we can loft. Use the loft command to loft along those sets of curves. So it's basically going to look at your trees and say, okay, I'm going to go to the list, loft along those, and then go to the next branch and loft along those, and do that for all 4 faces. So now what we have are 4 branches with 1 surface in each, and that's the lofted surface across all those contours, right? So, you know, let's do the same drill. Let's plug this guy into that, and now you see 1, 2, 3, 4, right? Turn off more stuff, right? So 1, 2, 4, and then it's a single tiered list. So this whole list item stuff, it's wrapping. So once it comes to the end of the list, it just goes to the end. Just so it's a single tiered list. That branch only has one thing in it. But so we have those surfaces, right? And so let's say I want to operate just on, let's turn off the other previews. Just say I want to operate on this face, right? I'm going to copy this out here just to keep it clean. But so let's say we want to just operate on this face now. So now we can go back to our lunchbox quadrangular paneling tool, plug that one face into that, get our number slider. So again, we got to do integers 4 to 16 or something, whatever you want. Plug those in together. And so that's how you can operate on a building. let's see, what's something else we could do to mix this up? So let's say you want to, okay, let's try to do something with this panel now. Let's try to offset this surface and make a smaller window frame within that. So you use the offset, it's offset surface. So let's just plug that in. And so it's looking at the surfaces and it's looking at the distance. Let's just put in a fixed distance. You can even just use a panel to plug in. Or you know what? Proper. I'll use one of these sliders. This guy. Or sorry, going on a non sequitur. The panels need to be. It needs to be something like 1, right? Something that's a small number. Oh wait, no. Let's try a different way. Let's just scale it. Right. So I'm going to try one thing. We'll put an area, plug that in, plug these in. Right. So you get the centroid that Tom had showed before. You plug the centroids in to the center of the scaling. You're going to plug the geometry in, and then let's just get a scale factor. Let's say we want to make them all 0.25 or no, 0.75 of the original, right? So there you go. So now you have windows. So, I mean, that's just a basic introductory step into like, once you have a grid, how can you keep operating on the grid? If we had more time, I think I would like to get into like, how do you really organize it? I think something that you should all maybe take this script and think about is how would you then apply patterns to this, right? How do you take what we know about list management and try to organize these branches in a way that you can do different patterns? Like maybe you want all the vertical strips, every other vertical strip to be 0.75 and the ones in between to be 0.6, right? I think that might be something for a later date, but I think that would be cool to talk about. Maybe if everybody could try it out on their own and just try to manipulate this sort of script, build onto it, think about it, and come back to it next time, and we can really discuss about issues you may have had or questions you had. But I think I maybe want to open up the floor to just general questions about the whole, everything we've talked about right now with the next 10 minutes that we have left. Any questions?
I have a question about the surface. So for example, if I have a building, one facade has a curvature surface, and when you use that subdivision tool to subdivide the surface and got those subsurfaces, and so because the whole facade is a curvature surface, and so for each subdivided surface is also a curvature surface. But when you when you reach the time that you want to, when you reach the time of construction, you hope that each subdivided surface to be a plane surface. So how do you transform from the curvature to the plane surface in this circumstance?
Well, yeah, I mean, it's that at the end of the day, everything that we're building is made out of straight components, right? Even if it's curved, it's smaller pieces put together. So we could even, let's try something, move face, face smooth, right? Smooth face. Or you can like rotate. I don't know, I'm just trying to curve this one, but
I got it. The way that I've done it is any curvilinear surface. The one that I made is pretty complex because it was double bending, right, in both directions, U and V in Rhino, and similar to what Anish is doing on screen right now. maybe this is a better example. Because if you had one of those panels, whether it's the window or the solid surface, there is a command called unroll. There's another command called smash, which is a little bit odd, but what that does is it takes curvilinear geometry and it flattens it or unrolls it to something that might be a sheet good, let's say like a metal panel. So if you had a complex curvilinear form and metal panel, and you wanted the contractor to understand the pieces and parts and the actual shapes of those parts as they would be fabricated and then installed and racked into place to form that curvilinear object, you can do that, and you could just kind of add on to the script that Anish has developed. So we would add things like unroll. We would add things like maybe a set of commands called open nest, which would actually flatten all those into a plane on like the floor or the ground plane, and it would separate them and number them in a kit of parts. And then that numbered kit can be given to a fabricator to machine all the metal panels, to organize them in their constituent parts, and then potentially using something like a drawing set or Anish's model, they can go out into the field and then install the panels in the correct sequence, understanding that they're going to be bent and racked into system for like fasteners back to structure, for example. So all those things are definitely possible. We've tried, and we can actually prototype those things in our laser shop if you want, which is pretty cool.
But it's worth noting that Lunchbox doesn't, like you can see that I curved the surface, right? And it's applying a rectangular grid to it, but the rectangular grid it makes is faceted. It's not a real curved grid. So if you really want to make curved panels, you kind of have to do your own math. Like Lunchbox is kind of a shortcut program where it gets you to that grid, but if you really want to make a really truly curved grid where the segments are curved, that gets more complicated and we have to really think about the math of it. But yeah.
It's very possible. One thing that's very interesting to note is that we're trying to develop an understanding, but also a set of tools. There is some resources on Emmy that you can go explore under design practice Grasshopper. There are scripts out there that we've used in practice. There's also some that are just fun or in progress where you can dive right in and play around. From everyone on this call and everyone in the firm, we'd love your feedback on types of things that you do in your general workflow or practice. We were thinking rectangular grids and facades and maybe area tabulations, things that we can save time doing, like tabulating area, but also we can get live feedback on complex forms in our building geometries. Once we build a thing, like this thing, and we'll share the link to the final script, which is nice and clean and has instructions for you. And how do we build upon maybe more ideas so that they relate to practice directly and maybe either save you time by automating a process for you, or maybe it's an idea of complexity that we can do something special like what Anish showed in his robotics project. Lots of possibilities. The one thing that people ask me is, can Rhino, can Grasshopper do this? I always think, I wonder. And every single time it's like, it can. It definitely can. We just have to figure out a way to do it.
I was just trying to show that you can also just start throwing numbers on your screen. This is a sloppy way to do it, but you know, it's just part of the potential. Any other questions?
I'm just
All right.
wondering if when you have like the lunchbox panel and then you inset it with the shrinking the area and you make another smaller panel, do you get a whole bunch of panels sort of stacked up on top of each other, or do you have to like cut them out with booleans first or something?
Yeah, you would, if you want, you can then cut it out, right? So yeah, there's trim with brep. So you could actually trim your region with another region, or trim with regions. There we go. I don't know. There's something for it, right? Trim brep with the brep, or what is it? Boolean difference. Region difference. There it is. It's always one of those. Region difference.
Yeah,
So
there's,
then
there's
bam,
ways to
bam,
do the same thing.
and then chill. So now you get the actual. Oh, but it broke.
You could like cut out the hole and then take that same sort of smaller shape and make and extrude it with a piece of glass or something, with a different depth or something like that, right?
Yeah, it's easier to work with lines, just the outlines, and then make your surfaces rather than like make surfaces and then chop everything together. It's, yeah, best to just consider your parameters, like especially the same way you make something in Revit, right? You think about what are the parameters, like you're defining guidelines, how do you set them? Set those lines and then build your geometry within it.
Cool, great.
All right. So I think we'll try to have a meeting next month. We'll try to keep pushing along these same lines. But if you guys have feedback, let us know. Any just like more complicated questions or any kind of questions along these lines, let us know. And we'll be back next month.
Yeah.
Tom, you have anything?
Thank you so much. No, I think that was great. Looking forward to continuing this thing, and thanks to Anish for putting it all together.
Yeah, thank you everybody for joining.
Thank you.
See you all.
Thank you.
Take care.
Thanks, guys.
Thank you.
Did we get all the questions in the chat? Just open that up. Looks like we did.